Okay, students, welcome once again to Dassault's online lectures. And today we're going to look at another interesting thing where we will be focusing on making biology so easy for you. In our last lecture, if you follow what we do, we were trying to look at the definition of the introduction into how evolution really occurs. And we defined gene pool as the addition of individual alleles in a population. We add all of them together and we have our gene pool. We also look at the equilibrium population, and we said that this equilibrium population principle was set by two scientists, Hardy and Weinberg. The idea behind this equilibrium population is that, assuming that there is a population where there is no evolution possible, and we agreed that this is hypothetical, it is never applicable in real life. So today we're going to look at the reason why equilibrium population came into display, and what are some of the conditions that Hardy Weinberg says. And this is why I finally introduce you to Hardy Weinberg equilibrium population conditions. Hardy and Weingberg put in places, they mentioned certain conditions. They said if those conditions are all followed, or they are possible, there is a chance for populations to come where evolution will not take place there. One of those conditions is there should be no mutation within the populations. Mutation, it is a source of genetic variation. It is because of the mutation I am different from my brother who I share same mom and dad. I am different from my sister who I also share same mom and dad, because we keep changing. There are changes that we are not even in control of from our genes. We have different genes, and these genes keep changing as well. So genetic variations. Hardy Weinberg says there should be a population where there is no mutation possible, and this is not possible. This is not possible in reality, and this is why Hardy Weinberg's population would always remain hypothetical. The number two that they said, there should be no gene flow. If you don't know what gene flow is the transfer of genetic materials or genes from one population to another, or the movement or the mating of individuals of different populations. For instance, let's say we have an African cow living in an Amazon. Within the same Amazon, you have another African cow population. Hardy Weinberg, what they say is, these two African cow populations, there should never a time that one member from the other population to go and meet another member of another population for them to mate, exchange of genes to occur. This is not possible in real life, because individuals are moving from one place to another, and during that process, gene flow occurs. Like you can have a sexual life with a member from different population. The third conditions that Hardy Weinberg put in place, that is, they said the population must be very large. You know what? If there is a small population, let's say 4 people makes a population, and there happens to be a genetic drift, you will realize that not even a genetic drift, but let's say if a population is very small, let's say 3 people, we expect these 3 members to be very similar to each other. We expect them to be very similar to each other. We expect all of them to be very similar to each other. But when the population is very, 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 very large, let's say 2,500 members of cow in a population, we expect a great variety of differences among this population. And when a genetic drift comes, it is not going to affect this population that much, as it is going to affect the small population. So I want you to take note on this. Genetic drift affect smaller population size than the larger population size. Genetic drift, it affects the smaller population size than the larger population size, because it is the drastic changes in the allele frequency of a population as a result of catastrophe or as a result of some other factors. So the fourth condition that Hardy Weinberg says, he says, all mating must be random mating. For individuals that are going to mate, it should all be random in nature. Like individual X should not mate with anyone that of his choice, or within its population, it has to be another person from another population. In reality, as long as you understand the animal life, all mating animal members of a population try to choose their own mating partners. They all tend to choose their own mating partners. So you can see how this principle is going to be hard for it to be applicable in real life. You don't have to choose your mate. You don't have to choose your own kind. So this is not possible. The fifth one, which is the last factor that Hardy Weinberg brought in place, is it says there should be no natural selection. Natural selection, if there is no natural selection, what that means literally is every genotype should have equal advantage and success. Like for instance, if there is no natural selection, we expect in human nature, everybody should be this tough. Everybody should be very, very strong. Everybody should be capable of doing what the strongest man on earth is able to do. But because of the natural selection and because of the genetic variations, we are different in terms of strength. We are different in terms of physical appearances. We are different in terms of our gene types and how strong and beneficial genes that we have in our systems. We can all share the same type of gene, but how beneficial this particular kind of gene is going to be manifested in my system will be different from yours. That is because of the natural selection. So natural selection is something that makes a particular genotype more beneficiary than the other. So we do not control this one as well, because natural selection is a driving factor which comes as a result of evolution and mutations. So Hardy Weinberg put in these 5 principles, he says for a population to be able to be called an equilibrium, or for a population to be state an equilibrium population states, all these 5 factors should be in place. If any of these single factors changes, that population will not be regarded as an equilibrium population. And I hope this video is really going to help. If you have any question regarding this particular topic that I discussed here today, you will feel free to put a comment on the video, then I will get back to you as soon as I can. But until then, I bet you to enjoy this video and feel free to always get back to me if you have doubts. Do not forget to subscribe to the channel. That is how we grow, and that is how we're going to help ourselves. Have a good day, students all over the world, and keep enjoying and following Danso's online biology, where I make biology the easiest thing